Oh my goodness. Thank you so much, Kate In-law. Much appreciated. Okie doke. Hi, folks. We're going to get started in about 3 minutes. Just giving folks some time to log on and get rid of those pre-roll ads. The pre-roll ads should theoretically be the only ads that you see, theoretically. And by pre-roll, I mean when you first connect to the stream. But I'm still figuring that out, so we'll see. And Rascal says that we have adjustable stream quality now. Okay, I have no idea what I did to get that, but I'm glad I have that feature now. I honestly don't know. There's a lot of settings. I'll just say that. But yeah, so we have channel points now. So feel free, while we're waiting for the timer to tick down here in the last couple of minutes, feel free to take a look at what you can do with those. And you'll earn them just like you do with Leon. A few channel points for every 15 minutes of watching. I think you get like a fair amount for being on a stream for like 10 minutes. So yeah, about the same. It should be the same accrual rate as you do on Leon's stream. So look forward to having some fun with those as well. And feel free to suggest if you guys think of any other channel point rewards you want to see, or any community rewards that everyone can work towards together. So yeah, I'm looking forward to adding more features to the stream. And I am working on getting some hype music to make the countdown timer a little bit more fun to sit through. If you're one of those early birds that waits, sits and waits for it to tick down. I got to make sure, though, I got to be careful that I don't find music, that I only use music that is suitable to use on a monetized stream. Because I'm nosy and curious, how did you come up with the name Mayan Wolf? That's one of those things. It's one of those things that I came up with in junior high, and it kind of just, because I was in junior high when the internet was really kind of just starting to pick up steam. I mean, I only had dial-up, right? But for me, being on stuck on dial-up internet, the like text-based forums were all the rage because I couldn't load video or images, so it all had to be text, right? And so it was one of those names. I was on a forum where everyone pretended to be wolves, and I'm sharing that with you guys because I value you, and but yeah, we all pretended to be wolves, and so that was my username on that forum, and it just kind of just stuck with me. I added the E on the end, but yeah, that's where that comes from. So do with that what you will. But yeah, with that being said, welcome everybody. Glad to have you all here. I was mentioning, while the timer was taken down before some folks might have joined, that we now have channel points, and you should accrue those. Let me know if you don't see those accruing after like the first half an hour or so. You should get them automatically, just like you do with Leon's stream. And I'm still working that out. I might be shuffling the rewards around, changing prices, that kind of thing, depending on if, how much they get used. But yeah, there's some fun stuff in there, so feel free to take a look. Hello. Yeah, hi. And again, a big thank you to Kate Inlaw, who used their Prime subscription and subbed to me. So thank you so much. But again, absolutely, I will never ask for subs. It's always appreciated, but I will never, ever ask you to sub to me. You don't have to. Don't worry. Feel free to just follow me so you get updates, and that's totally free to do. So just like with Leon, I won't ask you for subs, but I do appreciate it. So thank you very much. Channel points hype. Yeah, absolutely. There's some fun stuff in there. We got the usual stuff. We got the hydrate. We got the posture check, highlight the message, all that kind of thing. But then we got some more fun stuff. I have one in there specifically that you can spend if you want to remind me when I inevitably forget to add comments to the previous problem and I get an error. There's one in there specifically for that. And yeah, a few other fun ones too. Okie dokie. So let's go ahead and get into it. Today we're going to go over, good, cool, yeah. So I don't know, this stream may not be as popular as some of my last streams, but that's okay. Today we're going to go over some of the optional homework. So rather than being, normally in the past I've always gone over either a special project or optional or required homework. But today we're going to go ahead and go over some of the push work that isn't due until next Thursday. Yes, there is a cat cam. Yep, yeah, and you can hear him. He's ready for his debut. The cat cam is so expensive because I'm gonna have to buy a webcam because my laptop doesn't have a webcam. But the other computer that I've done some coffee video chats with folks on is actually my work computer, and I can do like free stuff on that for that, but I'm not going to do anything that involves monetization on my work computer. So yeah, he's here. But yeah, so we're going to do the optional homework. And so, this should be fairly chill, and the dog is here too now because the cat's getting attention. So the dog must have attention as well. So yeah, it all kind of just builds on each other. But yeah, I feel like the reason I chose to do the optional homework for this stream is just because, I feel like the more we get exposed to objects and do exercises with objects, the better we'll grasp it, right? And the earlier we get exposed and the more we get exposed, the better we'll grasp it. So even though this isn't due until next Thursday, and I could do this homework on, next Wednesday's stream, I decided to do it now, and get that early exposure so we feel more comfortable. Yes, it is a menagerie. I have 2 dogs, a cat, and I also foster cats for the animal shelter, cats and kittens. So, and I have a fish too. So yeah, I have quite a few animals. Okie dokie. I'm going to switch my screen over here. Fish cam. Yeah, actually my fish is pretty cool. He's a giant goldfish. It's pretty great. His name is Jake. Okay, so we should be on the code screen here. Can everybody see my screen okay? And according to Rascal, you can now adjust the video quality, apparently. I know that last stream there's a few folks that couldn't handle, like their internet couldn't handle the full 1080p, so unfortunately they had to watch the VOD instead. But hopefully now you guys can adjust quality. Okay, that's awesome. And I don't know what changed there, but I'm glad it did change. I want you guys to be able to adjust if you need to. So good. All right, awesome. So folks, yeah, if you're having frame drops or anything, feel free to, or buffering, feel free to adjust quality down. Okay, welcome at Random Gemini. Good to see you, and William Chando as well. All right, so let's get into it. There's 10 tasks, and the assignment was to read the whole objects chapter. So we're going to be skipping around a little bit. Not every subchapter actually had tasks in the objects chapter, but we're only going to do the ones that did have tasks, obviously. So the first one should go pretty quickly, and then they'll get a little bit more complex as we go. So any questions before we get started? And this is from the JS info reading, so you're welcome to have that open as we go. All right. Feel free to ask questions at any point, or feel free to yell at me if I make a mistake. You can also spend channel points when I inevitably forget to comment something. So here we go. The first one is from the very first subchapter in objects. It's just the one that's just called objects. So if you're following along, go ahead and flip to the first subchapter, and we're going to look at the tasks. Oh, you need the link? I can get you the link. Here, I'll post it in chat. Hang on. Objects. To that. I'm sending you the link to the sort of the tree where you can access all the subchapters as well. Yeah, you're welcome. Hey, Silent, how's it going? Good to have you here. Okay, so first problem is called Hello Object. And for this one, we're going to create an empty object called user. We're going to add the property name with the value of John, add the property surname or last name with the value of Smith, change the value of the name to Pete, and remove the property name from the object. Okay, so this is going to be a pretty simple sort of just an object declaration. And so if I was to declare an empty object, so if I say let user equal something, how would I declare an empty object? What would I use? Yeah, you got it, Random Gemini. Yep, and Florence. Yeah, you guys have got it. So we're going to use empty brackets for that, because if you remember, objects are enclosed by the curly brackets. So we're going to use empty curly brackets if we want to declare an empty object. Now, for each property in that object, yeah, you guys have got it. For each property in that object, we can basically use the dot notation to insert new properties into that object without having to be inside the object, because this specifically told us we're supposed to create the empty object. So we're going to use this outside notation in order to insert things into the object. So how would we insert something into the object from outside of these brackets? What kind of notation would we use? So for example, if I wanted to insert the property of name, yeah, we'd use dot notation, yep. And so what might that look like? Yeah, Lucas, you got it. Yep, user dot name. So we're going to say user dot, yeah, well, not dot this, because we are outside of the object here. So if I was inside of the object, this notation would be able to reference the object itself, but it doesn't know what it's referring to if I'm outside of the brackets. So in this case, we have to be, you have not done the reading, so should you do this class or not? Well, we're covering a lot of things that Leon has talked about. Not everything, but we are covering some things. Oh, hey, Lars, good to have you here. This is kind of an educational stream. We're part of basically a coding boot camp called Learn with Leon, or 100 Devs. It's the Learn with Leon Twitch channel, so you're welcome to check out Leon's channel if you want. And we have assignments and homework and that kind of thing that we get assigned. And we're reviewing some JavaScript object homework right now. So if you're interested in JavaScript and want to learn about object-oriented programming, you're welcome to stick around. Yeah. Floyd Wall, can you use brackets notation too? Are you saying can we do it inside of the brackets? Yeah, we could. It's not exactly what they specified for us to do in this problem, but yeah, you can build the object, by putting the properties inside of the brackets. Yeah. Lucas, I still don't understand this notation. That's okay. We're going to practice it a lot, so I'm sure you'll pick it up as we go. So in this case, we're just saying we've declared our object, and now we can insert things into the object from outside of the brackets by essentially we're calling the object here, and we're inserting the property after the dot. So we're going to say we wanted to say our user.name is John, user.surname is Smith. Oops. Capital letters. Okay. And user.name is Pete. Oh, and for those of you who haven't done the reading and maybe are thinking that they aren't going to be able to follow this this lecture, there's actually a live reading of this text that's going on Discord right now. Some of the lovely folks from the Women in Tech channel are doing a live reading of this text. So if you're feeling like you're not going to be able to follow, that's totally fine. Feel free to drop off join that live reading and then come back and watch my VOD later on. There's no problem if you feel like that's the better option for you. I did want to mention that because I know we're a little bit early on getting these problems done. Oh, bracket notation. Yeah, thanks, Rascal. I misread that. Thanks, Rascal. I think that's what they meant. Yeah. Yep. You can, in Rascal is right. You can also use brackets outside like you do with the dot notation. User bracket name equals John. Yeah, absolutely. Thanks, Rascal. I misread the question. Lars is asking, why did you use a semicolon in line 13 but not afterwards? Yeah, so JavaScript is, I don't know how familiar you are with JavaScript, Lars, but it's pretty flexible when it comes to semicolon use, and I'll admit I'm not the most consistent. But so, I mean, we could really do this mostly without, semicolons, but it just depends on best practice. I would say best practice is probably to use the semicolons, but like I say, I'm not terribly consistent with that. I'll go ahead and put semicolons on here. The last thing we need to do is, so we've added the properties. Now we need to also remove a property name from the objects. So how might we do that? How could we delete a property from our object here? Lars, you're coming from a PHP background, so it kind of, wow, PHP, that's intense. Yeah. Well, and I come from another language. I come from SQL, where it's a lot more strict about line endings and that kind of thing. So I feel you. I definitely do. It's the not having to be so strict about it is still pretty kind of weird for me. Rascal's giving some examples there on swapping bracket and dot notation. If you want to be crazy, yeah. Lars, set it to null to delete. I suppose we could, yeah, we could do that. We could say, let's try that. User dot name equals null, yeah. And then we'll say, oops, sorry, my dog is right next to me. Console dot log. Let's log this and we'll see what we get, okay? Yeah, so in this case, you see what we get? We get name is still there. Yeah, so we can set it to null, absolutely, but that doesn't remove the property itself, right? It just nulls the value of the property. So if we want to get rid of the property entirely, which is what's asking for here, yeah, Jenks has another suggestion there. We're going to say, whoops, sorry, we're going to say delete user.name. Let's try that. Okay, now let's see what we get. Okay, there we go. So now that did what we wanted, which was deleting the name property entirely. Yep. Oh, good, Floyd. I'm glad I'm glad that helps. Yeah. Yeah, there is a delete function, Lars. Yeah. JavaScript has a lot of things you can do. JavaScript is really, really flexible. Sometimes maybe too flexible, but it can do just about anything you can think of. Okay, so that's the first problem. It's pretty simple, right? We're just declaring an object and we're doing it, just literally, right? We're typing out each line of the object, and later we're going to get to constructors that can build objects for us, that Leon talked about in the last class. And so, right now we're writing everything out explicitly. Okay, so any questions on that one before we move on? Excuse me, I need to cough really quickly. Just one sec. Okay. All right, let's go ahead and move on to the next one. So the next question is checking for emptiness. Write the function is empty. Whoa, hang on. We've got a big one here. Yeah, so Florence says Eloquent JavaScript also has a great section on how bracket and dot notation are evaluated. Both value.x and value bracket x access a property on value, but not necessarily the same property. The difference is in how x is interpreted. When using a dot, the word after the dot is the literal name of the property. When using square brackets, the expression between the brackets is evaluated to get the property name. Okay, yeah, so one is literal, so dot notation is literal, and bracket notation can be an expression. Yeah. Lars, I do have a streaming schedule. You can find it on my channel homepage. If you just go to my channel, Mayan Wolf homepage, my schedule there is accurate, so you can check that out. Yeah, Rascal gives some more context there on the delete operator. Doesn't do anything with memory. It just removes the property from the object. Okay, thank you for the context, Rascal. Yeah. Alrighty, so next question, checking for emptiness. So write the function is empty, and it takes an object, and then it returns true if the object has no properties, and false otherwise. So it should return false if the object has any properties at all. So here's an example of how it should work. We declare an empty object here. We say let schedule is empty, right? And then we're going to have, I'm going to change this to a console log. Console log, and then we call that is empty and on schedule, right? And it should return true because schedule is an empty object. Now, if we add, and so here we're using bracket notation, right? Just like we just talked about. If we add 830 as a property to our object, we can set that, and we set that equal to get up. So it would be, essentially it would be 830 colon get up, right? Then we call it again. It should return false because there's now a property. So let's try that and then see what the results are in each case. First, okay, hey Snarfin, welcome. So this is from the objects chapter in javascript.info. So I believe if you scroll up a little bit in the chat, you should see a link to that, which I posted in the chat a little higher up. You can grab it from there. And thank you, Florence, for also providing the location of the additional context from Eloquent JavaScript. Much appreciated. Well, so if we, yeah, we could go back up here and we could look at how, how we would write it in dot notation. So we could say, now I'm not sure, can we do that in dot notation though? Because this is a string with some special characters. Well, let's try it. I don't know. Schedule, so it'd be schedule dot 830, right? I'm not sure this is going to work, but let's try it. Oh, sorry, Lars. You'd have to stay up late. Oh, that's too bad. Well, hey, I have VODs though. You can always come back and watch the VODs if you wanna have some background noise while you're doing something else. All right. So we're gonna declare schedule here. We're just gonna do this real quick, and then we're gonna forget about the function for a minute. We're just gonna test this here. We're gonna say console log schedule. See what we get. There's no harm in this, right? We're having fun. Throwing spaghetti at the wall. Yeah, okay, so it doesn't like that. And I didn't think it would because it's a string. So in this case, we do have to use bracket notation. Yep, now let's try it again. There we go. That looks better. Yep. Yeah, and Rascal, that's right. So you can use it with bracket notation. You can use the quote unquote forbidden characters. Now, there's some forbidden characters here, right? Because we've got a string and it's also got a colon in it, And we really just want to make sure that this string just gets passed in as a string, and this colon isn't possibly misinterpreted. And yeah, so it's just like dot notation, but more options for naming. Yeah, and like somebody said earlier, you can, Florence, right, I believe. Yeah, Florence said that. So the difference, when you pass in value.x and value bracket x, when using the dot, like Florence said earlier, when using the dot, the word after the dot is the literal name of the property. But when you're using square brackets, you can put an expression in there, you can put a string in there. It takes in the, whatever's in the bracket, it takes that in as an expression, and then it evaluates that to get the property name. So I felt like Florence really explained that really eloquently, so that's why I went back to reference their comment, because I think they did a really good job of explaining it there. Yeah. So that's why we had to do this one in bracket notation. But yeah, good question. It's always good to test this stuff, right? And see the application. So now let's go ahead and start building our actual function. So we're going to want to build a function called isEmpty. Okay, so let's put it down here, and we'll say function. Actually, wait, no, I want to put it up here because we're going to have a console log checking the empty function first. So is empty, and we're going to pass in an object, right? And now, what is the special way that we can do for loops on objects? How can we do that? What did we learn just recently that will allow us to do for loops on objects? For in, yeah, your passion, yeah, you got it. So we're going to say for, and then let key in object. Okay, and so what this is going to do is it's going to loop through each of the object's keys, which is kind of like the unique identifier for each item in the object. And let's see, I think the reading actually had a better definition of keys than I'm able to explain right here. But let me grab it really quickly. I like that. I think I like that definition. Hang on. Yeah. Well, essentially, a key is just the property name, really. So it's a string that's the property name, and then the value is associated with the key. Yeah. So we're going to say for let key in object, and then from there we're going to say essentially remember what we want to do is key is the property of the object. Yeah, well, it's the property name, I should say. To be clear, the key is essentially the property name. So the whatever's before the colon, right? If we look back up here, let's see, I don't have that anymore. If we were to console log this again, let's just console log this one more time here from the previous problem. Oh, yeah, I forgot to comment out the thing below, but so essentially the key is going to be the surname identifier right here. Okay? Oh, for of loop, same as for in. Oh, so you're asking, are they the same thing? So Rassel says for in loops through the enumerable properties of whatever you give it. For of lifts over the iterable properties, the iterable values of the thing, so not the same. So yeah, so enumerable properties equals the properties keyed by strings, and iterable are strings, arrays, etc. So for in is really just properties keyed by strings, and iterables can be strings, arrays, or more items. So yeah, I wasn't really sure of that distinction either. So that's appreciated, Rascal. Because I don't know that we've covered. Have we done both of those types? Because this is obviously a for in, and I was only aware of this being the main way to iterate over, or to loop through the keys in an object, right? Okay, let's go back to this. Yeah, and I didn't think we had. So for now, I mean, really just well, I think we did. I think we did for in a little bit. I think maybe we had like one example on it in class, which is why I was happy that that you guys did get it. Yeah, Irpassion got it earlier, so I think we've only seen like one or two examples of it. But anyway, for in lets you loop over the keys in the object itself. So it's kind of like for each, like you would do for each in an array. Yeah, it's kind of like you'd do for each in an array, except for in is exclusively for objects. Okay, so now let's think about what we want this function to do. So essentially, if the object has any properties at all, then we want to return false. If it doesn't, then we want to return true. So essentially, the for in loop will only be able to start at all if the object has at least one property. So what might we say in the body of this for loop if we know that when an object is empty, the loop will not start at all? This is a confusing one. Again, these questions are tricky. So essentially, I want to say if the loop is even able to start, the object has a property, and the value that is spit out of this function should be false. We'll test this in a minute if we don't get it right away. And we're going to test it either way, so no biggie. Okay, so essentially what we're going to say is all we need to say in the body of this function is return false. Okay, because if the loop starts at all, that means there's at least one key, at least one property. So if the loop is able to start at all, we're going to return false. Else, the loop won't run and we'll return true. And we don't need an else here because if there's nothing to run the loop on, it'll just skip it and it'll go straight to this return. So let's try that. Let's try it. All right. So we've declared our empty object here. And we're going to go ahead and console log just the first statement. Okay, let's run it. Yeah, so because it's an empty object, there's no keys, there's no properties, right? What happens when we go into this function? It says, okay, I have an object here, I've passed it an object. For let key an object, well, there's no keys. So there's nothing to loop on. So it's going to stop the loop and it's going to skip straight to the return statement down here. So we get true. Okay, now let's add a property to our object and we'll try again. Okay, oops, sorry, wrong one. Here, down here. Okay, so we're going to add a property to our object, and actually no, I'm going to do both. I want to console log schedule to show you the object with its property in there, and then we're also going to run the function. So clear this, run. Yeah, so now we've added the property of 830 to our object, right? So it has a key. So once we enter this function, there's a key that this can loop on. And so it's going to enter the loop, return false, and then exit the loop. And it'll actually, sorry, exit the function. Yeah, because we have a return statement there. So the return statement is going to kick us straight out of the function. Okay? And we're going to get some better examples of the for in loop. This one is really kind of hard to conceptualize because we're not actually doing any loops, right? Our object only has one property. So this function isn't super great for illustrating how the for in loop works. And Rascal says, we haven't learned it yet, but for those who understand methods better than this newish for loop, object.keys, and we pass in an object, returns an array of all the keys of an object, which one could check the length of to count how many keys the object has. Okay, so let's run it on this. I know it should show, yeah, so this is a fairly simple object, obviously. Let's do, oops, no, I want to keep that. And let's do this. Schedule, we're going to add one to the schedule. So console, I'm going to console log object.keys, and we are going to pass in our schedule. I think I can do it like that probably, huh? Okay. Yeah, so we can see that this returned the only key that this object has. So let's add an additional one to this. Let's do schedule dot I don't know, name equals school day. Let's do that. Clear this. Yeah, so we can see that it returned both keys in an array. The first key of 830 and the second key of name. Yep. Yeah, so, and I imagine then you could also perform other array operations on this Rascal, like the length, you know, right? And or any other array operation that you would normally perform. So this could be really useful if you have a really long object and you just want to simplify it. You want to see all the keys, or you want to check the length. Or I read we could use the has own property method of object. Yeah, I do remember reading about that. I haven't tried it, but in this case, would we just do? Let's see. Let me see if I can copy this. There we go. Is it like schedule dot has own property? Is that the right notation? Yeah, Rascal says all your favorite array methods can be chained onto this. I think it's worse performance, but we're baddies writing bad code. Yeah, I think most of our objects for the time being are to be fairly small, right? So, yeah. Let's see if I got this right. Or do I have to pass in schedule in the in here? Cranberry, do you remember? I remember reading about it, but I haven't absorbed it yet. That's okay. We can always come back and try that one later. But yeah, so that's fun. It's fun to mess around with this stuff and get more familiar with actually applying it, right? And seeing what it can do for you. So yeah, thank you for that. Okay, so let's go on to maybe a better example of the for in loop. Better example than this one. That actually lets us kind of apply it and loop through an object to perform an action on each key inside of that object. Okay. Let's do it. All right, the next one, some object properties. We have an object storing the salaries of our team. So see right here, very simple. Just got the names as the keys, right? And then simple integers as the values for each property. Oh, Rascal says, yeah, not even I've used or I think it says it's not commonly used. I think I read, but I might be wrong. If Rascal hasn't used it, then it's probably not very common. But it's still fun to try it though, even if it's not common, right? Like Leon does that all the time. He'll try something that's like crazy, like, off the wall left field, and he'll do it in class. So I'm up for trying anything. All right, so we've got our object here that's salaries, and we're being asked to write the code to sum all salaries and store in the variable of sum. Should be 390 in the example above. If salaries is empty, then the result should be 0. Okay. So I think I kind of gave it away, but we are going to want to use, again, we're going to want to loop through each of these values and perform an operation on each one, right? So let's declare our variable. We're just going to say let sum equals 0. And then now, what am I going to say here? We know the basic context from the previous problem, or the syntax from the previous problem. So what am I going to say inside of the parentheses here? Can anybody tell me? And we're looking at the object of salaries. Now, you don't have to tell me what's in the body of the loop. Just tell me the syntax that's going to be inside, or tell me the statement that's going to be inside the parentheses right here. Yep. Okay. Yeah. You guys are getting there. Yeah, you guys are getting there. Yeah. Yep. Yeah, so we're going to actually say for this one, since we're not putting this inside of a function, we're going to need to say let key in salaries. Salaries. There we go. Yeah, but you guys have the syntax down pat. Yeah, absolutely. Yep, for let key in salaries. Now, essentially what we're going to want to do is as we loop through... Oops, too many S's. That's a snake talking about their pay. Yeah, exactly. So now we're going to want to loop through our object, right? And for each loop, we're going to want to keep adding to the variable of sum. So in order to do that, I'm going to want to use the plus equal notation, right? Because that's going to take, for each time we loop around, that's going to take the previous value of sum and add the next value to it, right? So we're aggregating, we're getting an aggregated total as we loop through the entire object. Now, if we were writing Python, yeah, exactly. Man, you guys are on with the jokes tonight. I'm digging it. All right. Now, how can we control which object we're looking at? So essentially we want to say for each property in our object. But now we just learned that these are actually what are called keys, right? So, and we can identify those keys essentially using bracket notation. So what we're going to say is we're going to say salaries key. Now, this looks very similar to when we used to, when we do loops through arrays, right? If we did the for loop in an array, we would have let I equal 0, I less than whatever, I plus plus, right? We would have an I up here. And then down in the function body, we would say something like salaries I. But since we're looping through an object, we have the key, and we can just say salaries key, which will iterate through each key in salaries. Yeah, why not's got it. Yep. Good job, why not? Yep. So what this is going to do is it's just going to iterate through each key, add it to the aggregate value sum, and then that will give us the desired result. So we're going to console log sum. And we should get a total of 390, assuming I didn't forget any comments. Okay, there we go. Yeah, 390. And that would work, even if we had an additional, let's see, let's do Laura. And, forgot my comma there. and we'll give her a little higher salary of 200. So now we should expect the total to be 590. Yeah. So it doesn't really matter. The cool thing about this is that we don't have to necessarily know how many keys are in salaries, right? It just knows that it's going to keep going until it hits the end of the object. It wasn't like we had to say, you know, I less than equal to 4 or whatever. It just knows how many keys are, well, it's going to keep going until it doesn't have any more keys to loop on. And then it's going to exit. Yeah. And 2, notice here that we don't have a return statement, right? Because we declared sum as a global variable, it's available outside of the function, which is, you know, or well, it's available outside of the statement, right? And so we can console log it just as is. They better all have different rules or there's some pay inequity going on here. Yeah, absolutely. Yeah, that's why salary transparency is important. You should be allowed, especially in tech. I'm just going to little minor soapbox here. Especially if you haven't been in tech before, there can be big disparities in pay, just based on level of experience, specific roles, specific projects, that kind of thing. So, you know, talk about your salaries with your coworkers, get a good idea of how much they're making and why. So that way you can be a better advocate for yourself. So, and Vampy asks, and we don't use dot notation because we key is not the name of the actual property. Yeah, so key here is literally just referring to any of these names in the object. It's just standard phrase to say, hey, grab, count whatever, loop through everything that, loop through all the properties in the object, essentially. No, it's okay. Yeah, and Rascal says, remember how everything is an object. The for in loop actually works on a lot of things, like arrays. The key would be the index of the element in the array. Yeah, absolutely. Because I mean, you notice the notation is essentially the same, right? So here, let's get wild. Let's do it. Yeah, we want to evaluate the value of key and get whatever value it has and use that value as the key to access the value of. Yeah, it's confusing, but yeah, if you just think of keys as as the key that unlocks the value for each line, right? For each property. The key is going to help us locate and unlock the value for each property. Okay, so let's just say let salaries, and I'm just going to keep it simple here. We're gonna oh yeah, good. I'm glad that helps. Yeah, absolutely. So let's see, Rascal. If I just declare this as a numeric array, will it still work? Well, I don't know. Let's try it. Who knows? 160, 130. And 200. All right, now let's try the same thing. I'm going to clear this. Or do I have to declare them as... oh, no, it worked. Check it out. Very cool. Nice. And I mean, in this case, since it's an array, we could just use for each, right? But it is cool that it works in both cases. Yeah, it's wild. But the reverse is not true. So like for each will not work on an object. At least as far as I know. Rascal maybe knows better than I do, but that's what the internet told me anyway. Okay. Enough messing around. Should keep focused. I'm kind of scattered today, you can probably tell. But hey, we're having fun. Okay, I'm going to take a quick hydrate. Nobody's told me to do it yet, but I'm going to take my own initiative here. Alrighty. Any more questions on this one? Really great questions, and I'm glad that this is a much better example of the for in loop. Okay, thanks, Vampy. I'm going to hydrate again. I'm drinking black tea out of a mug with a bad word on it. So yeah, pretty good drink. All right, any more questions on this one? Great, like I say, great questions. Okay, well, we'll move on, but feel free if you think of any questions as we go, ask them at any point. It's okay. I don't mind backtracking. So if you ever have a question on an earlier question and you're like, oh, she's not going to want to roll back, I absolutely would. Yeah, and Rascal says for each to work on an object, it would have to be iterable, which at that point it would be a custom object with some special properties, and yeah. Okay, so next question is going to be multiply numeric property values by 2. So we're going to create a function called multiply numeric, pass in an object that multiplies all numeric property values. So any property value of object that is numeric, it should multiply it by 2. Okay, so they give us an object here called menu. Now notice, it has 2 properties which are numeric, right? And by numeric, we mean they have numbers in them. We have width and height, and then the title is not numeric. That's a string. Okay. And so they gave us this object that has 2 numeric properties and 1 not numeric. And then they tell us, we're gonna write our little function, call it, and then they give us what the value should be after the call. So after the call, it should be width goes from 200 to 400, height goes from 300 to 600, title stays the same, okay? And it says, please note that multiply numeric does not need to return anything. It should modify the object in place. So it's saying that you don't need to create a new object. And then they give us a little recommendation here. P.S. Use type of to check for a number here. So they tell us that we're going to need to do some checking to see what the type of each key is. Now, let's pretend we didn't see that, okay? We're just going to write our function as if we were just going to do it on each key, right? And then we'll add some extra conditions in there. So function is going to be called multiply numeric, because I want you guys to see what happens if we just try to do the operation on all of the object properties. Okay, and did I spell that right? Multiply, yeah, I did. So we're going to say for let key in object, because this time we're inside of a function, right? And we're passing in something called object. We're passing in a parameter called object. And so then that's what we use in our for loop. For let key in object. And we're essentially just going to say the key of the object should be multiplied by 2. So how could we say essentially multiply the key of the object by 2 and assign it back to that key? What kind of notation could we use here? So it's going to be object key something 2, right? So what do I put here? To multiply the item and assign it back to the same variable or key. Don't think about this one too hard. It's probably the first answer you think of. Yep, Florence has got it. Yep. Yeah, right. So very similar to when we did the addition back to the sum before, right? Yep. Yeah. So we could say let bloop in object, right? So let's do that. Okay, now we're gonna run this, and I need a console log down here. Console log menu. And now let's see what happens. Oh, Nelly, what happened there? So two things. First thing is that yes, we could say whatever word we want in here. Key is the standard notation, kind of like how you would use I in your for loop, but technically you can use anything. It just helps us remember what we're doing, right? We know that we're going to be iterating over the keys, so we're going to say, we generally say key, but saying bloop is fine too. But what happened here? So what we get back is width 400, that's right. We can compare it here as to what they said after the call it should look like. Width 400, height 600, title null. Uh-oh, that's no good. So they gave us a clue down here as to what we need to do to prevent this from happening. Now, I'm sure Rascal could probably explain why this happens. But yeah, when we tried to perform a mathematical operation on a property that was not a number, we get null as the result. So what they suggest is that we should use type of to check and see if it's a number. And then we only want to perform the operation. Yeah, silence by. That's essentially what happened, right? Is we said my menu times 2 is, and the result then is null. I would expect that it would be not a number, but maybe it just can't return not a number. So yeah, so we need to add some additional conditions in here, right? So we're going to add, inside of our for loop, we're going to essentially add an if statement. And we can use the type of to check whether or not our item is a number before performing the operation on it. So we can just say type of object key equals number. Now, what this is going to do is it's going to check the key, or sorry, it needs to be bloop because that's how I wrote it, bloop. So it's going to check whatever key we're at. It's going to get the property. It's going to get the value in that property, and it's going to say, is this a number? And if it is not, then it's going to skip the following operation here. It's not going to do the multiplication. So if it's not a number, it'll skip and go to the next iteration of the loop, right? So we can also, let's just get a little more fancy with this. We'll say title, I don't know, subject. What is it supposed to be? I guess it's not really. Italian food. And now we'll run this and see what we get. Actually, no, I'm going to put another number here instead. Width, height, depth. I don't know. 10. And we'll run it again. Oop, hang on. I have an extra bracket somewhere. Oh, I see. Forgot one there. There we go. Yeah, okay. That's good to know. That's good to know, Rascal. I actually didn't try this in the regular console. I was expecting it to get not a number back. And I was surprised when I saw null instead. So yeah, CodePen's interpretation of things is sometimes a little bit different than what you would expect to see, which is kind of unfortunate because CodePen is really good for these types of demonstrations. Yeah, and we'll actually see something. We'll see another representation of that a little bit later. That's kind of funny. I caught the second representation. I didn't catch this one, but yeah, that's interesting. Console log menu.title directly to see the real value. Okay. Yeah, that's good to know. Thanks for checking that, Rascal. So yeah, feel free to try this in the Chrome console and you know, without the if statement and see what you get back. Yeah, that's interesting. So, but now, because we did the check for number, it skipped this property, right? And then it just went on to the next one and performed the operation there. Yeah, Silent, every compiler has its own rule. Yeah. And it's weird, it's only for object. I know, Rascal, yeah, because I used CodePen previously for arrays, and it returned as expected, so just doesn't like objects for some reason. Oh, well. And there was something else I wanted to try here. Let me see if I can remember what it was. Oh, yeah, I wanted to try and see what happens when we put 10 as a string. Let's try this, right? Because let's see if JavaScript is smart enough to interpret that 10 as a number and do the multiplication. I honestly don't know the answer. I didn't try this when I did the tests earlier. So, oh, hey, look at that. Interesting. Yeah. Well, no, wait, that's as expected. I need to take the if statement out. I'm sorry. My bad. So we're going to take the if statement out of here completely. There we go. And, oops, not that far. Hang on. Take this out, yeah. Okay, now let's try it again. Blarg indeed, Florence, yeah. Okay, check it out. Check this out. And that's kind of what I expected, but I'm glad to see it's right. So it iterated through each one, right? And remember, we took the if statement out. So it's just going to try to loop through every single key. It's going to loop through every single key in this object. So it did 400, it did 600. Now it also did my menu. It's technically supposed to be not a number, but whatever. We'll let it slide. But it took in that string of depth and it saw that it was able to perform the operation, right? And we've seen that before. And so it took it in as a string, converted it to a number, did the operation on it, and returned 20. Yeah, and we've seen that before. JavaScript is pretty good about, yeah, type coercion. Yep, that's the word. Yep, type coercion. So, you know, to coerce something means to essentially force it against its will, and that's what's happening here. Right? It gives null. If you pass in, I'm assuming you say 10. Oh, yeah. Yeah, I think I see what you're saying, Silent. Yep. 10 plus 2, you get 102. Yeah, that's right. Because if you use the plus operator, here, let's just do this. We're going to plus instead. Yeah. Because remember that the plus operator pulls double duty when you're working with strings, right? When we use strings in the plus operator, we get my favorite word, which is concatenate, right? We concatenate instead of performing the mathematical operation on it. So yeah, so we can see what happened here is that it added 2 to the number, right? It added 2 to this number as well. For my menu, it concatenated 2 onto the existing string, and it performed the same thing for the depth as well. Yeah. And then Snarf asked, so Bloop is grabbing the key? Yeah, so Bloop is grabbing, so in this case, the key is width, height, title, and depth. Yep, and it's looping through each one. And I just changed it to Bloop to illustrate that it doesn't really matter what we put here. We could say key, you know, key is the standard notation, kind of like using I in a for loop, right? But you could use really any word. It knows what to expect. So if we run this again, you know, using key, we'll get the same result. Yeah. Same thing. So yeah, it's fun to mess around with types, and it's also good practice to mess around with types and operations and see. So that way you know what to expect, right? So I know that if I'm using the plus sign, I need to be careful and control for what happens if I have any numbers that are coming in as strings, right? I need to be careful about that because I want 12 here and not 102. So I need to make sure that what I pass in is truly a number rather than a string. So we'll run this again one more time. Oh, thanks if Dan can. I'm going to hydrate. Thank you. Doing it now. Yeah. So now, we get this. And, again, we still got that concatenate there, but not a big deal. We would just add that if statement back in, right? To have it ignore the string. Yeah. So this one was kind of fun. Messing around with types, seeing what we get back, and figuring out how to do a little bit of parsing of, to stop an operation being performed that we don't expect. Okay, any questions before we go on to the next one? Okie dokie. So now we're going on to the next sort of chapter subsection. We are on the object methods this subsection. So if you're following along in the js.info text, you can go ahead and go to this this subsection. It's really hard to talk about this because it's so grammatically ambiguous. Yeah, it's really hard to discuss it verbally. All right, so first question, using this in an object literal. So here, the function make user, so we're given a function, right? They gave us the function already written out. Here, the function make user returns an object. What is the result of accessing the property of ref? Okay, so it's got a couple more declarations down here. So let's look at what it's doing or what it's trying to do. Console log this instead. Yeah. Okay, so it's essentially saying we've got this function and it says make user, and then we have a return statement in here of two properties, John and a ref property that just it's supposed to return this. Then down here we say let user equal make user. So we're setting user equal to this function up here, right? And then we're saying console log user.ref.name. Okay, so essentially what that is we're saying console log make user dot ref, which is this dot name. So this is really confusing, but do you guys have any thoughts on what might come back? Make user, essentially it's going to be, what this is saying is make user dot this dot name. We can always just run it and see. John, that's a good guess. Yep. So let's see what happens. Let's see what we get. I'm gonna run it. Oh, hello. Hello. We got back code pen. That's interesting. Lol indeed. Airpassion, we are on we're on the object methods, comma this. That's the subsection we're on. Object methods, comma this. And we're doing the first question, the first task in object methods. Okay. Yeah. So what this is essentially doing is remember that this notation. So if we say something like, this dot whatever, this dot name inside of a function, this is going to return instead of a method. I'm sorry. If we call this from inside of a method, so if I have a method that's here, well, I've got an example. We'll let's see. So if we modify our function a little bit to place this inside of a method instead of just inside of a function, we'll get more of an expected result. Oh, thank you for sharing that link, Rascal. Much appreciated. Yeah. So remember that this is supposed to be used inside of a method. And I'll show you why in just a second. I have to rerun this. So we're gonna put this inside of a method. And now, if we run this again, oh, hang on. Oh, sorry. Commented out one too many lines there. My bad. Oh, and I also didn't change my console log. I'm sorry. There we go. So, because I'm calling the method now. I think that's it. User ref.name, yeah. Yeah, now we get John. Okay, why? Right? Because this notation returns whatever is before the dot. So in this case, let's dissect this console log right here. So what am I doing now? So I'm calling user, which is equal to make user. So essentially I'm saying make user. And then the next thing I'm calling is ref inside of make user, which returns this. And in this case, this is equal to, since this is inside of a method, this is now equal to make user. So essentially what I'm doing is I'm calling make user.name in total. Make user.name, which returns John. So that's super confusing, I know, but just think of this, the word this inside of a function as returning whatever is the parent to that function. Okay? So if you think of like a parental relationship, in this case, ref is a method inside of another function. And what that's doing is it's going upwards and it's saying, what is my parent? My parent is make user. So this is going to return make user. Now, let's go back and look at the first statement again. In this case, this is not contained inside of a method. So it's saying, I'm being asked to return this. And so what is the parent of make user? Make user has no parent. Make user's parent is the window in which it exists. So the window, that's why the first time we ran this, it returned CodePen. Because there was no parent to make user. So it returned the global sort of window where the function exists. The parent is the window. Which is pretty wild, huh? So that's why when we're to use this, the global object, yep, exactly. You're exactly right. And in some cases, I think this is another quirk of CodePen, like we were talking about earlier, and that I believe in the text it says it will return undefined, but in the case of using it in CodePen, it returns the word CodePen, which I think is great. Yeah. So in this case, this is not contained inside of a method. So it says, hey, I'm inside make user. Make user's parent is the global object, so I'm just going to return the name of the global object. Yeah, and Russell, that's a good comparison. It's like the descendant CSS selector. It'll locate the ancestor that matches or the parent that matches. In this case, the first parent context that exists. Right. So make user doesn't have a parent, so this is going to return the global object. But down here, or sorry, up here, sorry, my bad. Make user doesn't have a parent, so it returns the global object. But down here, we've enclosed this inside of a method. So it says, hey, what's my ancestor? What's my parent? It's make user. So essentially we reduced that console log down to make user dot name, which returns John. Yeah. I know it's wild. We're going to get some better examples of this here in a minute. If you're not following, that's totally fine. This is more one of those like theoretical sort of concept questions. That's not always the easiest thing to follow. So don't worry. We'll do some more examples of this here in a minute. Okay, let's go to the next one. I also found the explanation in the text. If you look at the solution for this problem in the text, I found the explanation really awkward. So I hope I was able to explain it slightly better. And Rascal, you had a good comparison there to CSS. But I don't think you'll probably have this problem very often. Because most of the time I think we're going to be using this correctly. But you never know. You'd want to know what the reason was. If you ever got undefined back, you'd want to know why that would be. So it's important to know that. All right, so next one, we are going to create a calculator again. We've done this a couple times, but now we're going to do it with our advanced knowledge of objects. Oops, sorry. I want to uncomment this part. Okay, so we're going to declare, so it says create an object calculator with 3 methods. Read prompts for 2 values and save them as object properties. Sum returns the sum of the saved values, and multiply, or mul, multiplies saved values and returns the result. Yeah, everybody increment their calculator tallies for the number of calculators that they've done. Bonus points if you were on my very earliest YouTube stream, where we built a calculator using an incredibly long series of if statements. Now we're going to be able to do it in just a very few lines. So it's really cool. We're getting better, right? No more crazy long if statements anymore. Unless we want to. Hey, Snarfin was there. Yeah, all right. And now for the push work, if you guys have looked, for the push work this week, if you want to, if you have time, Leon is asking us to build another calculator using object-oriented programming methods, and then also commit it to GitHub. So yeah, take a look at that if you haven't already. So you get to build another one. Bonus points, that's like calculator 5 or 6. Okay, so we're gonna have calculator, and then we're gonna want to, in the end, we're gonna want to be able to call calculator.read, calculator.sum, and calculator.multiply. Oh yes, Snarfin, that's where you learned the plus trick. Yeah, way back in the day. I feel like a hipster. I was doing the plus numeric conversion before it was cool. Yeah, absolutely. Okay, so inside of calculator, we already kind of know the things that we're supposed to have, right? Because they're being called down here. So we know we need sum, and it's going to do something. We don't know that yet. And we need a multiplication method. So and it needs to be called mul. And we need one more method that's called read. Actually, no, I'm going to put these in a different order. So read is actually going to come first, because read is going to get the user submissions. It's going to prompt the user for numbers, and then it's going to pull those in. So then we also need another one, this last method here called read. Okay. And also too, make sure that whenever you're putting either properties or methods inside of an object, this is one place where punctuation is necessary. You need to remember your commas. It's kind of similar to how you do an array, right? Each of the array elements is separated by a comma. Same thing for objects. The comma is required. Yep. And I tend to forget it, but then you'll notice that it doesn't, the next items won't turn the right color until you include that comma. Yeah. Okay, so for our read method, what do we need to do? It says it prompts for 2 values. read prompts for two values and saves them as object properties. Okay, so we already know how to prompt the user for a value, right? We can just use prompt. Now, what do we do? How do we assign a new property to an object? We've done it before. How do we assign a new property to an object? It's the very first question that we did. Remember that first question where we created an empty object and then assigned properties to it? Yeah. You guys are getting it. Yeah. And CRA, yes, you're right. Yep. You're actually a little ahead of me there. Perfect. So yeah, we are, in the very first question that we did, we're going to scroll back up there real quick. I still have something I didn't comment out there. Sorry. Remember the very first question that we did, we declared an empty object, right? And we assigned properties using dot notation, essentially saying user dot name equals whatever, user dot surname, blah, blah, blah. Now, since we were outside of the object, when we did it, we had to explicitly say user dot whatever. Now, this time, since we're inside the object, when we're doing that property assignment, we can just say this dot num a, or whatever we want to call it, essentially, equals something, and we're taking in two numbers, so we're going to say again this dot num b equals. Okay. Yep, and you guys were all right in slightly different ways, which is awesome. You guys are all on the right track. And Ciara, you went ahead and were correct in suggesting this notation. Absolutely. And now why does that work, right? Because we are inside of our calculator, right? And so it knows what this is. And we're inside of a method too. That was just the previous question that we did, right? We said if you use this inside of a method, it knows to say, hey, I'm inside of a read method. What's the parent of read? It's calculator. So instead of having to say calculator.num a, calculator.num b, we can just say this. Because we're using this properly. We are inside of a method, which is inside of a larger object. Okay, anyway, how do we prompt a user for a value? In this case, I just want a little window to pop up asking them for a number. You don't have to give me the specific, prompt. Yeah, easy question. I said it already, but it's good to just review this stuff. Yep, you guys have got, oh yeah, and Silent Spy coming in the clutch there. Yep. We also want to make sure that what we get is converted to a number, no matter what they give us, if possible to do the conversion, yeah. So yeah, we're gonna use the plus operator and prompt together in beautiful harmony. So we'll just say enter the first number. And then we can also add a default value here if we want to. So we'll just say 0 for default. And the second one is going to be just essentially the same thing, except change the wording slightly. Enter the second number. Okay, so that takes care of what the user is going to see. So we've got the input, right? We now have num a and num b created. So if we want to sum those two objects, those two properties together, we want to say return essentially this dot num a. Again, we can use the this notation. this dot num b. We're just adding them together, doing math. And for multiplication, again, pretty much the same. We're just going to return this num a multiplied by num b. Okay, I think that's everything they asked for. Yep. All right, let's try it and see if it works. What does this mean? Yeah, z-suffix. So this is essentially kind of a shorthand that when you use it inside of a method that's inside of an object, it looks for that method's parent and essentially substitutes that in. So at the time of the call, we're saying instead of having to say calculator.num a, calculator.num b, calculator.num a, calculator.num b, we can just use this to refer to the parent object at all times. And if you want more information about what this is specifically, what the this notation can do and cannot do, go ahead and refer to the text, the javascript.info text that we're actually doing these example questions out of. There's a whole subsection of the chapter on exactly what this notation is and what it can do. And I think we should be able to find that, grab that link for you again. Yeah, Rascal shared it just a little bit higher up, but I will also share it again. Oh, kind of got it. Yeah, take a look at that. I just pasted it in for you there. And definitely get familiar with this and when you can and can't use it. Because the previous question that we just did essentially explored that and said, what happens if you try to use the this notation outside of a method, right? In this function, it's outside of a method, and so it tries to look for the parent of the function that it's in, or of the object that it's in which this case has no parent. So you can't use it there. But yeah, take a look at that and explore some of the use cases. But in general, you're gonna use it inside of a method to refer to that method's parent object. Okay. Yeah, and Leon did touch on it a little bit in the last class. So if the javascript.info text isn't making sense, you can also refer to the previous class, Leon's previous class. Yep. All right, so let's try it. So let's see if I made any mistakes or forgot any brackets anywhere. I think I'm good on my brackets. Yeah. Run this. Okay, so we're going to enter the first number. Let's do an easy one. We'll just do 10 and 20. And 20. And yeah, so the first operation so I forgot what we called. Yeah, so I should have console logged this. Whoops. So we called sum first, right? So it added 10 and 20, and we get back 30. I know that's probably really small. I'm going to console log these instead. And then the second operation we did was multiplication, which returned 200, which is correct. But I'm going to console log these for you. Everything in js.info always says alert on all of the examples. I wish they would just console log stuff. All right, let's do it again. Okay, so let's do 50 and 10 this time. So we expect to get back 60 and 500. There we go. Yeah, that's what we wanted. Yeah, so this is a pretty nice, it's a nice little, compact way of essentially encapsulating all the calculator operations that we want to perform, encapsulating them into, into a nice clean package, right? Because previously we might have, just declared a bunch of different functions or had one really long function, and generally that isn't really necessary anymore. We can just pop them all into one very nice clean package with clean notation. Was the read method meant to just capture num a and num b? Yeah. Yep. That method. All that method did was just prompt the user for the two numbers and then assign them, and then essentially it added those, right? It added those as properties inside of our object. It created num A and num B because those didn't exist prior to us doing this prompt and getting the values back. Yep. Oh, bye, Vampy. Yeah, thanks for joining. See you next time. Feel free to catch the VOD later on. This is this is probably gonna be one of my shorter streams, honestly. We've only been going for an hour and 30 minutes, and I think we're like halfway done. So that's wild for me. Oh, posture check. Okay, yep, good call. I'm kind of sitting sideways. I'm gonna mute for just a second because my chair is really loud. Hang on. Okay, there we go. And Rassel says, and this making small making small functions / methods that do just one thing is super helpful for making the code clean and future maintainable. Yeah, and Leon has mentioned that several times, is that eventually we want to get down to where our functions or our methods really just do one thing, right? They do one thing and they do it well. And then they return that value somewhere else to do the next thing. So previously we'd gotten kind of comfortable with writing big old functions that did a bunch of stuff all at once, right? But the goal is to eventually get to the point where each of our functions has a single assigned task, performs that task, and then passes on to the next, method or whatever. So, yep, that's a good reminder. Oh, hey, Ciara. Hey. Yeah, good to have you. Love to have you here. Yep. Glad you're able to join us live. Zsophic, why does the prompt have a plus before it? Okay, I'm not going to answer that. Somebody else in chat want to answer that? You all know what it does. That's a good question, Zsophic. We got to keep reminding ourselves of these little shorthand notations that we can use to make our lives so much easier. So yeah, I put that question to the chat. Yes, excellent answer, Florence. Yep. Yeah, y'all are coming in hot. Yep. Y'all are exactly right. Yeah, good. I'm glad that helped you, Zsophic. Yeah, it's much faster than writing number parenthesis, right? Yeah, exactly, Lucas. Yeah. Yeah, welcome back, Lucas. Yep, so we use the plus sign to convert it, much simpler, much faster than writing parsant or number. It just using that plus sign attempts to turn a value into a number if it is possible to do so. Yep. Pro tip, yeah. Yep, and I was excited that Leon finally mentioned it for the first time in class, in the last class. Yep. Yeah, the spread operator, that's good too. Yeah, I don't think I've had cause to use it on stream yet, but I have used it in Code Wars. Yeah. Do your Code Wars. If you're not doing Code Wars, do them. Do them Code Wars. It's a super great way to learn little new tips and tricks. Even if you're not getting the questions right, even if you got to look at the solutions, that's totally fine. You're still going to learn something, right? That's what Leon keeps saying. We already know this from mine. Yeah. Like I said, I was talking about the unary operator before it was cool. I'm a hipster. Need a plus sign hipster beanie. All right. So any other questions on the calculator before we move on? Zsophic, that's okay. Be sure to check in with the catch-up crew if you're not there already. They're a great bunch of folks. And if you want to review any of my older streams, I've got the last 4 or 5 as VODs on my channel, on my Twitch channel here. If you want to see streams that were from before I moved to Twitch, on the 100 Devs Discord, in the House Hamilton or Women in Tech channels, you can go up to the very top. There's a little hashtag icon. You can click that and it'll show you threads. And I have dedicated threads in both of those channels for my older YouTube streams. So you'll find them all there. It's probably another, 5 or 6 streams that you can also look at, which cover older material. So I hope that helps. And yeah, and there's no harm in falling behind. There's tons of folks in the catch-up crew. It's just going things at your own pace, right? better to go at your own pace than go too fast and burn out and then stop altogether. So yeah, life happens. Okay, next question. Chaining. This is interesting. Okay, so I'm gonna make sure I unhighlight the right stuff here. And this. Okay, so we're gonna do the first part, this first sequence first, and then we'll do the second sequence. How many hours do I give in a day to review Anki? I don't know. It depends. It depends on how I'm feeling. It depends on, have I just added a new concept? And if I've just added something new, something I'm not at all familiar with, then I'll definitely take more time. It really varies. I try to keep it at the pace where I don't ever feel like I'm getting too repetitive or burnt out on Anki, because I think it's important to keep it as a sort of a fun, engaging, cognitive experience rather than just rote review. So yeah, I don't know that I can give a straight answer to that question. Just do it every day. It doesn't matter if you do it for 5 minutes or 30 minutes. Just do whatever you can, all right? I think there's too much, it's got to be careful not to put too much emphasis on like counting the minutes that you do something. Other than like limiting yourself to 20 minutes on Code Wars, that's important, just to not let your brain burn out. But like forcing yourself to do, like anytime you feel like you're really forcing yourself to do that sort of review or that sort of thing, that can get dangerous, because then you can get burnt out. If the alternative is not doing it all ever, then you might have to force yourself to do things sometimes. But yeah, just be careful. Try not to burn yourself out by saying like, I'm going to do 3 hours of Anki. Like, no, don't do that. Yeah, chaining is super fun. Yep, and that's the next thing we're going to be doing here. So next question is chaining. There's a ladder object that allows, there's a typo here. There's a ladder object that allows you to go up and down. So we have an object here. It says let ladder equals, we start at step 0. Then we have a method called up, which increments our step value. So ladder.step plus plus, so we add 1. We have another method that says to go down, so we increment, we iterate down step. And then the last one is show step. So that's going to give I don't want an alert, I want a console log. So then we're going to console log whatever the current value of step is at that moment. So the first thing that it has us do here is multiple calls to each of the methods inside of our object. And each time we use since we're outside, right? We're outside of the object, we have to use this notation of ladder.up, down. So specifying ladder each time so that it knows what object we're referring to. So let's run this and we'll see what we get. So remember, if we start at 0, we're going up, up. So that should be 1, 2, down. So we're down back to 1. Show step, right? We should get 1. Down again, show step should be 0. So let's run it. Yeah, and that's what we get. We get 1 and 0. So all that's as expected, but this is kind of cumbersome. As Rascal was saying, just listing each of these out independently, there's a lot of repetition here, right? So the next task is to modify the code of the methods up, down, and show step to make the calls chainable like this. So they give us this statement here where each of the methods are chained together, right? So they're all referencing ladder, and they say up, up, down, show step, show step. So again, we would expect to get the same result of 1 followed by 0. But let's run it and let's see what we get, okay? Oh, snap. Okay, now to make this a little clearer, we're going to change this just a little bit. I'm just changing it a little bit. I'll put it back, but I just want to let's run this again. Yeah, so this makes it a little clearer. So we get uncaught type error. Cannot read properties of undefined reading down. Okay, so let's see what's happening. So it looks like it's reading ladder.up just fine. But then as soon as it tries to read the first chained item here, with the first chain method of down, it can't. It doesn't know what to do with this. Okay, and it's the problem is asking us specifically to we're gonna have to make modifications to the code of each of those methods in order to make the calls chainable, because right now they are not chainable. It's able to execute this first one because it has the proper notation of ladder.up. But once it gets to the second one, it doesn't know what to do. So I'm gonna put this back to the way it was. I just changed it to down to show you clearly that it was failing on the second chained item here. Okay, so let's look back up at the notation here in the methods. So what keyword have we previously seen that lets us essentially return the parent value of a method? What have we seen? What have we used previously to return the parent value of a method? Pop quiz. I'm going to hydrate. Yeah. CR's on it. So we can use this, right? We can use the keyword this to get the parent value of a method. So if I said return this, because right now this method doesn't return anything, right? It's just taking this internal step value and it's performing an operation on it. It's incrementing by 1, but it's not returning the value, right? Until we get to the very end, and that's when we console log it. But up until then, it's just doing internal operations on the step value. Now, but if we add the return statement that passes the parent of the method out of the method, now let's see what happens. So let's think about what's going to happen. So if I run, sorry, I'm just going to delete this so it's clear to see. Now, if I run, so ladder.up, that's going to work. We already saw that this first one is going to work. Now, if I run, and so it's going to run up. It's going to increase step by 1, but it's also going to return the parent of the method. So it's going to pass the value of ladder out of up, which will essentially carry over to the next up. So essentially this becomes, from ladder.up, it becomes ladder.up. And then we're also going to have down return this as well. So it then becomes, once we finish executing up again, it becomes ladder.down, because we're passing out ladder each time. We're returning ladder each time. So we execute down. And then we get ladder.showStep. And now we also need to add a return statement to showStep. So essentially what we're saying is that, in silence by, we're essentially returning the parent each time we execute one of these chain functions, so that the next chain function that's executed knows what object it should be attached to. Okay? So we're returning the value of the object, which is ladder, so that the next function in the chain, so the next method in the chain knows what object to look for. Okay, so I'm going to backspace just a little bit here. Oops, too far. Return this and return this. Okay, but don't take my word for it. Let's try it. So I'm going to run it. Yep. And I think I deleted an extra up statement there. So let's put the up statement back. Ladder dot up. There we go. Okay. One more time. But now, essentially, the chaining works. Yep. That's what we expected. Shows 1, then 0. Yeah. So this is kind of wild, but in order for the chaining to work, each subsequent method has to know what object it belongs to. So the keyword of this can only be used inside the body of the object. Yes, you're correct. And it can really only be used correctly inside of a method inside of the body of an object. And we looked at this in one of the earlier problems, but I think you were doing something else at the time. You were away from the stream. So essentially if you try to use this just inside of the object itself, what this does is essentially looks for whatever the parent of the thing that it's inside is. So in this case, it's inside of the method of up, and the parent of up is ladder. So it returns ladder. Now, if we just put it inside of ladder, it would look for the parent of ladder, which is the global object or the window where it resides. And so that's not what we want. But yes, you're correct in general. Yeah, JSWay chapter 6, which explains, yeah. Yeah, kind of. Or if you want a reference to the object after calling a method on it without saving that reference first. Yeah, because this will always know, what its parent is. Yeah. Okay, sure. Yeah. Yep. However you want to think about it. And there was a question up here. Let me see. Sorry, I'm scrolling back up. How would it know which object that it belongs to? Well, that's essentially what we're doing by returning this each time we run a method, right? So down here in our chain, we are outside of the object. So unless we specifically tell our program, unless we specifically tell the chain at every single step what object up and down belong to, it doesn't know. It's not going to remember. And so by having each time we call the method, having it return the object it belongs to, we're essentially reminding it. So we're saying the first time it knows, right? It knows it belongs to ladder because we explicitly use the dot notation there. Now, the next time, so we call up, right? It returns the parent. It says return ladder. And then, so the next time we call up, it says, oh, I belong to ladder. I'm gonna run ladder.up. And again, it returns ladder. So the next item in the chain knows, hey, I belong to ladder. I'm gonna run ladder.down. And again, and again, and again for each item in the chain. Is return this only necessary for when we do chaining? Yeah, and that's what Rascal answered earlier. If you want a reference to the object after calling a method on, yeah, so chaining, yes, yep. Or if you want a reference to the object after calling a method on it without saving that reference first. Okay, good deal. Yeah, glad that was helpful. Yeah, it's kind of wild when you think about it. That the fact that we can replicate that whole long list of calls of saying like, ladder dot up, ladder dot down, whatever, that whole chain, we can replicate that whole chain or that whole list by essentially chaining the items together as long as we keep reminding each of those methods what their parent is. Yeah. Pretty funky. like Rascal says, it makes you feel like a magician. You can just chain all these bad boys together. Yeah, chaining is fun. Okay, any other questions on this one? Let's see. So we are on the objects chapter of js.info. If somebody wants to share that link, that would be much appreciated. And we are looking at the, let's see, what was that subchapter called? We are on the object methods, comma, this. Actually, I think we're just finishing that one. I think we're about ready to move on to, we're just about ready to move on to the constructor subchapter. That one right there. Thanks, Sierra. And Rascal, thank you. Yeah, and we're just moving on to the constructor subchapter, operator new. Yeah, that's essentially a reasonable way to think about it, Florence, I think. So the following chain, does it make sense to think if we didn't do return this inside the method, the following chain method is referring to the previous chain method, i.e. ladder.up.down, where down would refer to up and not the ladder object. Yeah, I think that's a reasonable way to think about it. It just doesn't know, it tries to reach back and figure out what object it belongs to, but yeah, it can't find it because there isn't one there. There's another method there. And so in the case of us returning the object from the previous method, then it says, oh, okay, I see that I have this value sitting here that was given to me by the previous method, and that's my object. Yep. Chanpo's asking for a quick break. I was just about to say, no. Sometimes it's good to write these things out, right? And by writing them out and by talking about them, you get a better understanding, and it can help somebody else understand too. Yeah, so don't apologize for that. You're fine. Okay, so yeah, let's take a quick break. We're at about the 2-hour mark, and my dog is, one of my dogs is freaking out because his dinner is 20 minutes late, so I can hear him in the other room. So we'll take 5 minutes. Is 5 minutes enough? Gonna be good for you guys? Let me know. Whoops, stop. Yep, okay. Yeah, all right. We'll set it for 5 minutes, and I will see you guys back here very shortly. All right. Time starts now. And welcome, Bear. Sound Gouda. All right. See you in a little bit. Okay, we still got about 30 seconds or so you still got a little time to come back. Alrighty. Welcome back, welcome back. Hope you enjoyed the break. Yeah, and Silent, I will explain those. The Silent asked if I could explain the new channel points challenges or options, and so I'm happy to do that. Yeah, so we got a few new channel points opportunities for you guys, and let's see, the 1,000 channel points opportunity is just one I thought was kind of fun. You know how Leon occasionally does polls on his streams where he asks a question and then we give an answer. And so I just added that on as a fun option. So you could potentially suggest a poll for me to give to everybody in chat and see what their answer is. Whether it could be like, you know, how many of you guys have gotten a freelance client or you know, or just something, anything that you want to ask the rest of the group. That might be a fun thing to do. The next one is IRL word ban, which I thought would be kind of fun. And if you click on the challenge, you can read about it. The IRL word ban is that I can't say a specific word for the next 5 minutes. And so that could be any word. It could be object or function or concatenate. You can just prevent me from saying a word for the next 5 minutes. Word of your choice. Obviously, a word that's suitable for work. You know, nothing, something that I say often, nothing absurd. The next one is nana cat cam, which is the opportunity for me to go buy a webcam and solely to fulfill the dream of getting my cat Bart visible on stream. And I'm happy to share his face and my face as well. I don't mind. Yeah, that's what that's for. Then the last one, the most expensive one there is called Next One's on You. And that one is where you get to pick, essentially what the next stream is going to be about. So it'll be up to you, whatever you want me to cover, obviously within the bounds of the course, just something, you know, whatever you want me to talk about, I will devote the next stream to covering that thing. Oh, Rascal's getting devious in there. Imagine not being able to say the word the or a. Oh man, you could do that if you wanted. I could try. 5 minutes might be a little long for that one, but. And Ryan asked, do you do push-ups if you mess up? Yeah, I don't don't think there's any punishment. I really think it's just, you know, best practice. But I mean, I could tell you I was doing push-ups. You wouldn't know, right? I could just like clap my hands and be like, 1, 2, 3. Yeah, you know. I don't know if I could do more than a few push-ups. I'm kind of scrawny. Yeah. The IRL one is interesting. Yeah, you know, I wanted to give you guys some options that might be fun or interesting or stuff you might want to save up for. Yeah, just have a little fun with it. If you guys have suggestions about another one you think might be fun, I'll definitely take it into consideration. Not going to say that if you suggest it, I'll 100% implement it, but you know, it's fun to play around with challenges and give you guys some ways to contribute. So. No need to snitch. Yeah, exactly. Okay, well, let's get back to it. So we just finished learning about chaining, and we're getting ready to get into constructors. Okay. So constructors. So essentially, if you recall, you know, what a constructor does is it allows us to essentially create a factory that can create an object for us without us having to manually type out each object property, right? So we can have a function that essentially says, you pass in maybe a couple of arguments, right? And what it spits out is a full, complete function with probably some additional properties that you declare inside your constructor. Oh, do a Code Wars problem live. That might be an interesting one. Yeah. You have to save up the channel points for it. Yep. Save them up. And there's some other things I could do with channel points too. I'm thinking about, like, you know, I can do that betting thing where that's a built-in thing that I could trigger, that allows you, to like Leon did, you bet on the outcome of the rock paper scissors or whatever program he codes, and then we win or lose channel points. So far I've only lost channel points, but not a lot. I'm not a big gambler. YOLO indeed. Okay, but anyway, let's go ahead and look at constructors. So the first question there is 2 functions, 1 object, and it's asking, is it possible to create functions A and B so that the constructor A is essentially equal to B? And they give us function A and B. And we set the variable A equal to whatever the output of constructor A is, and variable B equal to whatever the output of constructor B is. And then we want to alert the result. Or console log the result. Console log, yeah. Okay, so it's basically just asking us if this is possible. So can we build these constructors so that A is equal to B? So this is kind of this is one of those kind of theoretical questions. And so I'm actually going to, hang on one second. Yeah, okay, so let's think about this. So if I wrote my function, sorry for the noise there, if I wrote my function to return, essentially inside of a method. If I wrote my function inside of a method to return this, it would just return the parent of whatever it gives. But there's a specific situation where instead of returning this, we can return something else. Yes, we pass the same value. That's not entirely the case. So I'm actually referring back to the text here really quickly for the because I feel like it did a decent job of explaining. This is kind of a weird property that it even said that it's not super common, but hang on. Yeah, okay. So usually constructor functions don't have a return statement. And so what they do is they write properties into this, right? So we'll say function A, this dot, I don't know, item 1 equals stuff, and this dot item 2 equals, let's say we pass in a parameter of 1, this dot item 2 equals, parameter of thing, this dot item 2 equals thing, and that helps us build an object, right? And so we don't generally need a return statement inside of a constructor. Okay. If there is a return statement, so if we're asking the constructor to pass something back out, if return is called with an object, so if the return statement is returning an object, then the object is returned instead of anything associated with this. If return is called with a primitive, so like say a number or a string, then it's ignored. And it gives the text actually gives an example here. So I'm just going to pull this up really quickly. That's what I was digging out there in a minute ago. Come on, there we go. Okay, I'm going to zoom in. Okay, so here we have our constructor called big user, right? And what it's doing is it's assigning this dot name equals John. But we also have a return statement that returns an object where name is Godzilla. Now, if we call our constructor and say new big user dot name, will it return John or Godzilla? In the case where the return statement returns an object, just the way it is, it's going to return Godzilla instead of John. Okay, but if here I'm just gonna grab this here. We're gonna mess with it a little bit. Instead of me typing it out, I'm just using the example. So before we even go into the actual problem itself, we're gonna look at this example here. And I'm gonna comment this out for just a minute. We'll come back to it, I promise. Okay, so we have this function big user. Now, let's look at it again. And so we have big user. It sets this dot name equals John. So if we just had this line and we call big user, console log it, let's see what we get. We get John, right? Because we asked for big user dot name, and in our declaration here, this dot name equals John, so big user dot name is John. Makes sense. Now, if we have a return statement that returns an object where name equals Godzilla, and we make the exact same call to big user dot name, will we get John or Godzilla? Well, clearly the comment here tells us that we're going to get Godzilla, but let's double check that. Godzilla. Okay, so why am I even talking about this? Well, let's see what happens if I return something else. Like, we'll take the object. Let's do return. We'll just say return Godzilla. Okay. Okay, now we're back to getting John, because what I'm trying to return is not an object, so it doesn't care. It ignores it. The same if I tried to return a number. Nope, back to John. Okay, now let's think about the actual problem we've been given. So somebody said earlier that we can make the results of our two constructors functionally equal if we pass the same value. Okay, let's try that. So we have function A. We don't need to pass anything in. It's not required. Let's just set this dot item 1 equal to stuff. Okay. And we'll also do the same thing for B. We're going to do the exact same thing, right? So if we make them functionally the same, then checking whether they're equal should return true, right? Let's see. Let's see what we get. Ooh, snap. Well, I also forgot to comment that out. Okay, now let's do it one more time. Uh-oh. Huh. So despite the fact that these functions are built in literally, that these constructors are built in literally the exact same way, using the same property and setting it to the same value, it still didn't work as expected. Now, why might that be? Well, let's think about it. Because we're using the keyword of this, it's not, it's still keeping them as, it's still identifying them as essentially completely different end results. So when we set A equal to the result of constructor A, it's setting it to, it's still keeping it, it's still identifying that they belong to two different constructors. So when we try to see whether they're equal, the result is no, they aren't, because they have two different sources. Now, if instead of using the this keyword, if we use the return keyword, let's just add it on here, and explicitly return something. So we're gonna, instead of trying to grab what exists inside of the object, we are going to explicitly return something outside of the constructor and assign it to A and assign it to B. Then it should work because we're forcing the return. But like we just said, what is the only thing that I can return out of a function that it will let me do? Like, what is the only thing I can return out of a constructor that essentially will overwrite the this? What did we just do? What did we just do in that example earlier with John and Godzilla? What's the one thing we're allowed to return? Object. Ta-da! Yeah. So we can return an object out of both of our constructors. And if we return the same object, so we say let object equal, we can just set it to an empty object. So let object equal object, empty object, doesn't matter. If we say return object, so in this case, both constructors are going to return the exact same object. Let's see, do I need a comma there or not? I don't remember, sorry. No, I don't need it. Okay. Return. So now both constructors are passing literally the same object back out. So now let's do our check again. Yeah, now it returns true because A and B are both evaluating to object. Yeah, and I can actually completely get rid of the this statement and it'll still work. Yeah. Oh yes, another yep. Yeah. So essentially, we're saying, regardless of, I know these two constructors are different, but they're both going out and returning the same result of object, they're both evaluating to the same object. And so then when we do the check, the result of each constructor is going to be the same thing, gets assigned to these two variables. We check and see whether they're the same, and they are, so we get back true. This is another one of those conceptual questions. It's a little bit hard to parse, but we're gonna do a real constructor here in a second. Yeah, yep, it will work without the statements above the return. Yeah. Now let's do one more thing. Let's make these completely empty. Okay? Let's have them not return anything. Do the same thing. Yeah, again, we get false. So even without the this keyword, it's still seeing these constructors as two different objects, right? So what we need to do is we need to override that and say, hey, no, forget about this. Forget about any implicit properties within the constructor itself. Forget about those. Go look at this outside object instead. Have both constructors look at the same object, and we're essentially tricking it into saying, oh yeah, actually, they are the same. They're both looking at the same object. Yeah, it's a little trick. I don't know if it has any real practical application, but it's an interesting little quirk. Yeah. So let's actually build a real constructor that does something useful. Okay, so the next question is, guess what? We get a new calculator, another one. Everybody increment your calculator counters. We should have a calculator counter for how many calculators we've done. Let's see. Again, we're being asked to create a calculator, and this time we're being asked to create a constructor function called calculator. It creates objects with three methods. Now these should look familiar. We've got read, which reads in the values. Sum returns the sum of the properties. Again, yeah. And mul, which returns the multiplication of the properties. Okay, so we got our constructor here. We're calling it the calculator equals new calculator. We call read. We're console logging the results. Yeah. Again, another calculator. Again. Yeah, I'm gonna be doing calculators forever. Okay, so essentially, we're calling the constructor, we're having it prompt, and then we're having it do the sum and multiplication methods. All right. So, since we're making a constructor, we're going to declare it here with capital letters. And for those who who were involved in, I think it was my previous stream where we also looked at js.info homework. We did a constructor there without really knowing that it was a constructor. I mean, Rascal knew, but we hadn't covered it yet. And so we actually did one of these before. So kind of interesting that was in a previous reading without explicitly identifying it as such. But so now inside of our constructor, we are going to have a method called read, and so we can identify it as this.read. And inside of that, so we're going to have a function that's going to do two things. It's going to prompt twice, and we're going to prompt the user twice for two numbers essentially. So we can say, again, we can call this dot num a equals prompt provide first number, and we can set a default value to 0, and we also need the second number. Set that to num b and provide second number. And Rascal's giving some explanation there. Okay, yeah. So maybe as we get more advanced, we might find some more applications for it. And Rascal, I think what you're referring to is the return versus this, right? Is that what you're referring to there? Yeah, thank you for the extra context. Okay, so we've got our calculator, let's see, we've got our first function, which is the read, or first method, which is read. And I'm sorry, I have to sneeze, 1 second. barely got it muted in time. Golly gee. All right. So we've got read, we've got our prompts going there. And then the next method we need is this.sum. Oops, can't spell. Function. And again, we're going to return this dot A plus this dot B because we're summing the two together. Okay, yeah, thanks, Rascal. Yeah, when we were returning something from the constructor, Rascal gave a little bit more context there on the first problem about when we, you know, the context of this versus return. Yeah. Okay, so we got the sum, and the last one is multiply. So essentially, we're just going to say this dot mul function, and we're going to return this dot A times this dot B. Okay, so that covers, oh, sorry, yeah, Numa and Nom. You're exactly right. Yep, good catch. Thank you. Anybody remember Numa? Yeah. Early internet gem. Okay. So I think that's all we need for that, for the actual declaring the constructor. And so now the reason why in this function we don't have a return statement is all we're doing is we're just assigning properties here. We're just setting this .num A is equal to whatever the customer passes in, right? Whatever they give us. Now, in the next one, we do need to return because we want to pass the result up and out to essentially give the result of the method, right? So here we do need return statements, okay? Because we want to pass those upward and make those be the result. But here we don't need one because we are just assigning properties. Okay, so where did I accidentally delete the actual calls? Oh, no, here. I'm going to put these down lower. Can move these down below. Makes more sense. Okay, so we're setting calculator equal to new calculator, and we are calling read, sum, and mul. So oops, and you're right, Silent caught it. I made another mistake, but that's okay. It'll still run. Yep, good catch, Silent. Okay, so let's just do small numbers. We'll do 2 and 3. And 3, so I expect I should get 5 and 4 because I made an error in my second function. Yep. So sum equals 5 and multiply equals 4. Yep. Yes, indeed. Okay. So I'll fix this just for completeness sake, and we'll do it one more time. 2 and 3. There we go. That looks better. Yeah, so I mean, this looks very similar to what we did before, right? Except we're just putting it into a constructor. And I don't know if this is the best illustration of a constructor. I like the example that Leon did in class, which was, you know, building a car, right? And it had some things that were essentially pre-populated properties, right? And then some that were, you know, passed in as arguments to the constructor. And I think that's probably a better application of constructor rather than this. So I would suggest maybe looking back at the example that Leon gave in class if you're still not quite sure about the value of constructors and what they can do for you. Because yeah, it's a great way to quickly build objects without having to key in every single property, you know, manually. So yeah, check back on Leon's examples, or just grab the files from class, and you can see, kind of what he did there to quickly build a car with only having to pass in a couple arguments to the constructor, and then out pops a whole object with a whole bunch of properties, which is pretty cool. Okay, so any questions there? Oh, hydrate. Thank you. Doing it now. Drinking my tea, which is now very cold. I didn't make a fresh cup during the break because I had to feed my dogs. Sacrificed tea for giving my dogs their dinner. But it's all right. I don't mind cold tea. It's refreshing. And here in the U.S. anyway, that's kind of like a classic staple is iced tea, right? I don't know how common iced tea is in the rest of the world. Does anybody else in the world who's not from the U.S., does anybody else drink iced tea? Or does everybody drink hot tea? Just a little cultural question there. Do Canadians drink iced tea? Me, okay, awesome. I'm honestly not sure. I wasn't sure how common iced tea is outside of the U.S. I would think it might be too cold in Canada to drink iced tea, but maybe that's an overgeneralization. Kinda. In the Philippines, iced tea is always iced lemon tea. Ooh, that sounds good. Lipton's iced tea. Hey, that counts. Yeah. Okay, was just curious. Well, if you're watching this VOD later or watching on YouTube, feel free to shoot me a message on Discord with if you are outside of the US and you do or do not drink iced tea. I am genuinely curious to know. Okay, so last thing we're going to do here. I doubt it'll be the sugar-loaded iced tea I'm thinking, having lived in the South. yeah, southern folks in the US do. They generally like to dump quite a bit of sugar in their iced tea. I personally don't. I don't like it. I lived in the U.S. state of Kentucky for a while, which is not technically in the South, but it functionally, culturally, it is. And so, of course, iced tea, or particularly sweet tea, is really big down there. And so I always had to hunt at any place that did have tea. I had to hunt for either hot tea or iced tea that didn't have any sugar in it. People thought I was a monster. Yeah. No sugar in your tea. Then it's just dirt water. Yeah, there's an argument to be made there. Yeah, without sugar, it's just water with leaf juice in it. So yeah, that's a take, certainly. Yeah, Tennessee, Kentucky. Yep. Man, they love their sweet tea. That's right. They had opinions on tea. Yeah. Strong opinions. Okay, next question. Actually, this is the last question. So we are wrapping up. This is like a marathon stream on my terms. Man, only 2 hours and 30 minutes? This is the shortest stream I've done in like a month. Hey, not that that's a bad thing, though. Like, I'm not trying to be a marathon streamer. My streams just go long. Although I have been hitting the hour goals to be partner, like, before anything else. Oh, boy. Okay, so last question. Create new accumulator. So we're going to be creating a constructor function called accumulator, and we're going to pass in a starting value. So the object that it creates should store the current value in the property value. And so, okay, this is a really confusing the worded sentence. So let me read it again. So store the current value. So whatever the current value is at that point in a property called value. So value : should hold current value, right? Okay. The starting value is set to the argument of the constructor, the one called starting value. Okay. Oh, somebody else redeemed hydrate. More cold tea for me. All right. I hydrated. Thank you. All right, so the starting value is set to the argument of the constructor, the one called starting value. So essentially, just we're passing in a starting value. That's all it's trying to say. And now we also need to have a method called read, and it should use a prompt to read in a new number and add it to value. So essentially, we're going to keep we're each time the read method is called, it's going to ask the user for a new number and add that to the property of value. Okay. In other words, the value property, so the property called value, is the sum of all user entered values, starting with the initial value, starting value. Okay. So here's what they want us to be able to do. So we call our constructor, we call read, we call the read method twice. So we'll be adding two user submitted values to the initial value of 1. And then at the end, we want to be able to console log the results. Okay, so let's see how we can do that. Okay, so the first thing we want to do is we want to take in a starting value, right, and assign it to the property of value. So let's declare our doohickey here, a constructor, accumulator. I keep saying what? Keep saying read, and I sit up straighter, thinking I'm being called an, oh, is your name Reed? Sorry about that. Well, so my real name, it's on my Twitter, so it's not a secret, but my real name is Claire, and there was that one class when Leon was doing the bachelor code, and he kept saying he was going through and eliminating the bachelorettes that didn't make the cut, and one of them was named Claire, and he was like, we don't want Claire to be visible, we want to get rid of Claire, and I'm like, man. I didn't really mind, but it was just funny talking about eliminating Claire. Yeah. Okay, so let's walk through this. How would I essentially create a new property inside of my object? How would I create a new property with the value of essentially whatever we pass in here? How would I do that? I want to create a new property called value with a value of starting value. So can anybody write that up for me? Just that one statement. This dot value equals starting value. Yeah, you're right, Snarfin. Yep. Yeah, so we're going to say, oops, sorry, hang on. We're going to say this dot value. So we're creating a new property, and yep, Silence got it too. Yep. And to value, we are going to assign the value of starting value. I've never said value so much in my life. All right. So essentially, if I pass in 1, right? If I pass in 1 to my constructor, it's going to say, oh, accumulator.value now equals 1. Now, why do we need that? Well, remember that each time the user is prompted, we're going to add the number that they submit. We're going to add it to our value property. Okay, so we're going to have a function that's going to then prompt, called this.read, and it should prompt the user for a number. So we know how to do a prompt, right? And we want to essentially add it to the existing number that is currently, existing total that's currently sitting in value. So we're just going to say this dot value, take whatever's in there, and add whatever the result of this prompt is. Also converted to a number. So initial value is going to be 0. Okay. And so essentially this is kind of similar to, like, we're kind of creating like a reduce kind of situation, right? We're creating a running total, and it's almost like it's, you know, kind of like the loops that we've done before, except in this time, in this case, the loop is triggered manually. So each time we call the read method, it's going to prompt and perform this operation, right? So it's kind of user controlled. We're calling it, and we're triggering this as many times as we want. Okay, so that looks good, I think. And what do we need to call here? We need to say, I'm going to put these down below. We're going to call our constructor. We're going to pass in 1, and then we should get 2 prompts, 1, 2, 4 values, and then we want to log the result. Okay. Did I comment out the previous thing? I did. Yay for me. I've had a lot of changes without saving. There's been 45 changes without saving. Yeah. All right. Let's pass in 5 and 10. Yeah. And then the result is 16, right? Because we passed in 1, then we called our read method. That asked for a number. I passed in 5, and so it said, all right, take the current value of the value property, add 5, and then we called it again, and we added 10, and then after all of that, the total result is 16. So let's do something a little different. Let's run it again. And this time I'm going to pass in 5, and I'm going to pass in, actually, no, I don't need to do that. Never mind. Yeah, forget that. I was originally going to say I'm going to pass in a number and a string, but then I forgot for a moment that each time and this is something that's good to remind ourselves of, the result that you get out of this prompt is always going to be a string. So whatever you get back from that, it's always going to come back as a string, and so that's why we do this conversion here. So no matter what they pass in, it's going to be a string. We want to convert it to a number, so we do that here. So that's a good thing to remember when you're using prompt. I don't know that we'll use it too much outside of just exercises, but yeah, good thing to remember. So I would say this is fairly straightforward. Does everybody understand what we did here? The fact that we took our, we took in an argument. Yep. Awesome. Yeah, this one wasn't too bad, right? Kind of just builds on some stuff that we did before. Yeah. Okay. Yeah, we took Champo. Okay, that's fine. We'll go over it again. No worries. You're allowed to say you don't get it. That's totally fine. And I am going to save though. I haven't saved this entire time. There is an auto save, but for some reason it doesn't work. I don't know. Probably doing something wrong. All right. So what we did is we declared our constructor, right? And we said we gave it a parameter of starting value that we can pass in. It's only slightly better than arrays. Yeah. Arrays and objects are kind of gnarly. Yeah. And that's why I wanted to do this tonight. Like I said earlier, I wanted to do this homework tonight, even though it's not due until next Thursday. So that way we've covered it. We can think about it. You can revisit it. You can go do it on your own. And it's just more exposure, right? We just got to get more exposure to this stuff because it's a very different sort of, if you haven't done coding before, or even if you haven't done object-oriented coding before, which I haven't, SQL, the language that I use, it's not an object-oriented language. It's a declarative language. So essentially, sorry, I'm going to digress just slightly here. With SQL, it's declarative in that you tell it the problem. So you tell the computer what problem you want to solve, and then the computer goes and solves it however it wants to. So you don't control necessarily how the problem gets solved. You just tell it the problem. So I would say like select fields X, Y, and Z from table alpha. And I'm not telling the computer how to go get those fields or what order to get the fields in. I'm just saying, go get them. And So depending on the way I write, depending on the way I phrase my question or phrase my request, it could be very efficient or it could be very inefficient. I have no control over that. I mean, there's things you can do, but it's all about the phrasing of the question, of the request, of the query. So this is a different thinking about actually, writing out the objects and the functions and telling the computer how to solve the problem. It's not something I'm familiar with either. So it's fine, to take our time and learn these new ways of thinking. Yeah. And if you're interested, you can look up the different types of, we've heard of, object oriented, programming. It's interesting. You might look up the different types of programming languages that are out there and how they're different. And why they're created that way. And there's a Wikipedia article on it, and it might be worth a read if you're at all interested. Because like languages like Fortran and COBOL are one type, and SQL is declarative. JavaScript is object oriented. It's just interesting. Different ways that they get stuff done. Okay, so anyway, let's go back to this and let's walk through it again. So we've declared our constructor, right, called accumulator. And we're saying that we're going to pass in a starting value, which is what they told us to do. They said it needed to accept a starting value. Okay, so we said, yep, we're going to pass in a starting value. And the very first thing we're going to do is we're going to create a new property called value. Okay, and we're going to set it to whatever starting value we pass in. So in this case, if we pass in 1, it's going to say, okay, accumulator.value now equals 1. The next thing we're going to do is we're going to declare a method here. We're going to say this.read, because that's what they told us to create. They said we need a read method, okay? And it should use a prompt to read a new number and then add it to the existing value. Okay, so essentially what we're saying is prompt the user, have them enter a number, use the unary operator to convert it to a number if it's not, because it's going to come in as a string, so we're going to convert it to a number. And they want us to add it to the existing value property. So now we're saying this.value, so accumulator.value should equal the starting value. Essentially, here's what we're saying. We're saying starting value plus what we've brought in with our prompt. Oops, sorry. Starting equals starting value. There we go. But then that's only going to work for one call, right? So it's better if we just use this notation. So we're saying take whatever's currently sitting in the value property and add to that what we get back from the prompt. And so now every time this method is called, so let's say the first we call this method once. So we call accumulator.read. Okay, and we've already passed in a starting value of 1. So we pass in a starting value of 1. We call accumulator.read one time. And I get a prompt saying, give me a number. I pass in 5. Now let's see what happens. So we've already set our value property equal to 1. And so it's saying, okay, 1 plus 5 is 6, right? Okay, so if I were to console log after the first call, accumulator.value, we're going to console log after each call and you'll see what happens. So going to pass in 5, right? And now get a console log. Oh, thought I was going to get one. Maybe it's behind there. I can't see it. And then I'm going to pass in 10 for the second time. Okay, yeah, it did. It just delayed the console log until after it had finished. So the first time I console logged it, I got 6 because it took 1 plus 5 and returned 6. And the second time I called it, it remembered that 6 was still sitting in the value property, right? And so when I entered 10, it added 6 to 10. Does that help, Chanpo? Oh, Airpassion, you did some MySQL. That's awesome. Yeah, and SQL is kind of interesting in that the actual syntax is not hard to get your head around. It's the relationships that are the hard part. Yeah, because you got to think about how your data is interrelated and the ways that you can ask that question. Remember, because being declarative, you're doing the query, you're asking the question of the computer to return exactly what you want. You don't care how it's returned, you just want the right stuff, right? And so you have to ask it in the right way to get exactly what you want in a reasonable amount of time. It can be very easy to mess that up, believe me. Awesome. Good deal. Okay. Well, that was the last question in the js.info. But not every subchapter in the js.info chapter on objects actually had tasks. So I would highly suggest go back and read all of the subchapters. Even if they don't have tasks, go back and read all of them. And if you don't have time, I know this is push work, so you might not have time, and I totally respect that. Not everybody has the time to do all the stuff, and this was optional. So at the very least, maybe check out the summary for each subchapter, and at least get a feel for what's happening. And you can always just look at the solutions for each task as well. Like Leon says, looking at the solution still gives you a taste of what's happening. So yeah, that was pretty much it. Anybody have any last questions before we wrap it up for today? Yeah, Ciara, good. Yeah, and that's right. Typing it out can really, really help you feel what's happening. And as you're typing, it forces you to go a little slower, right? Because you can only go as fast as your fingers. And so you might, as you're typing something out, you might be like, wait, why am I typing this? What is this doing? And that makes you go back and look at the text and say, oh, okay, that's why I'm typing this. Versus just looking at it, you might skip over stuff that doesn't make sense immediately without realizing that you're skipping it. This code pen, well, silent. So just so you know, there are solutions in the text as well. But I can share the code pen link. It's fine. Save it. See. Whoops. Hang on. I didn't mean to do that. I forgot to comment my code. And I also had this uncommented up here the whole time. It's a mess. Comment this out. Okay. See, can I share it directly from this page? Do I have to go back to the home page every time? Anybody know? Rascal redeem. You're a little late there, man. Good timing though. Rascal redeemed. You forgot the comments again. Nice. Little posthumous reclamation there. Let me see. Can I share it now? Stream delay. There you go. Lower right share button. Oh, okay. Thank you. You know what? I couldn't see the button because the way I have my setup, I have my laptop in front of my external monitor where I'm doing this work, and I literally couldn't see the lower right hand screen. Okay, I'm going to copy the link and I'll just pop it in chat. Thank you guys. Yeah, I physically couldn't see it. First try. Yeah, darn right. So there it is. Yeah, although, I'm sharing this with you only because the solutions are also in the text. So if the solutions weren't in the text, I wouldn't be sharing this. And please don't just go and copy this. At the very least, go look in the text, look in the solutions, type out the solutions on your own. If you can't do anything else, go into the text, type out the solutions on your own, and then, submit your own typed out versions of the solutions. Okay? Cool. I'll take that as, yeah, no problem. I'll take that as agreement. Okay, awesome. All right, any other questions before we wrap it up? I'm going to save this too. Doesn't have to be about the homework, could be about anything. Oh, has everybody tried setting up their GitHub accounts? If you haven't, I would highly suggest that you do. Sooner rather than later, watch the YouTube video that Leon shared for basic Git commands. That YouTube video is super duper duper helpful. So definitely carve out 20 minutes of your day to watch it. Yeah, absolutely 100%. No, that's fine. It's just a reminder. You got plenty of time. But sooner rather than later, watch that YouTube video, code along, get your GitHub account set up. And just start practicing the commands. That's what I've been doing. Yeah, and like I say, just follow along with the YouTube video, and that can be your first time pushing something, and doing a commit and a push. Yeah. If you're brand new to GitHub, I wouldn't worry too much about organization just yet. Just get familiar with the commands. Remember what they are and do them. Practice them several times. And I would also suggest use learn the command line commands. Like Leon said, the command line might seem scary, but in the context of Git, I really think it's simpler to use the command line commands for working with your repository and just pushing and pulling and committing. I think that is easier than actually using the interface on GitHub, because the interface on GitHub, there's a lot there, right? The GUI on GitHub is there's just tons of stuff, versus using the command line, very simple, straightforward, clean. Oh, you push your daily code words. That's awesome. Yeah. Working in the terminal makes me feel like such a hacker. Yeah, darn right. Absolutely. You're coding. I know. I remember the first time I used the command line, I was so scared because I thought I was going to break my computer. Yep. That's awesome that you push your daily code wars to GitHub. Yeah, and Rascal, that's a good point. Once you know the command line commands, you'll know how to work with almost every other interface, from web interface to GitHub desktop to VS Code, built-in Git integrations, you name it. If you know the command line, you can learn them all easily. Yeah, and that brings up another point. VS Code actually has some pretty great integration, as far as I've seen so far, has some really good integration to GitHub. It reminds you whether or not you've committed your changes. It has little indicators. It keeps track of it for you. Push and pull with VS Code is really simple, but the terminal will be more beneficial. Yeah. That's a good point. VS Code does have, built-in stuff. But yeah, learn the command line. But if you learn the non-commands first, then you might have to do some relearning when you change interfaces. Yep, exactly. And that's the same thing that Leon said, right? He was like, learn the command line commands. Don't mess with the interface, the GitHub interface. Because you're not really going to learn anything if you do it that way. And normally I'm like, normally my philosophy is that the GUI is better, just use the tools that you're given that make things easier for you. But in this case, I agree with him that the command line codes are so simple and you only need to know like 5 of them. And the YouTube video walks you through it hand in hand. And if you find something that you are trying to do in GitHub that you don't have a reference for yet, the Git manual is actually really really nice. So this is the Git, just not GitHub, just Git. So the basic tool that you installed on your computer, their documentation is actually pretty awesome. You can search for stuff so I needed to learn how to create a new branch. So I just said, let's see, I think I just Googled for like create branch. And so I found this article called Basic Branching and Merging, because that's what we have to do for the calculator project, right? Is we have, so for Leon's calculator push work, if you get the chance to do it, you have to know how to create your own branch of the code and then merge that branch back when you're done. And the videos that he shared so far don't necessarily tell us how to do that. So I looked up the documentation, and this walks you straight through it. It's really, really great documentation. So get-scm.com. I'm just going to go back to the homepage here. Documentation. Yeah. So hit that up if you need it. And like I said, search function is really great. And it's an awesome reference. And Silent, you asked the question, class will be on next Wednesday. I assume you're asking about my next stream? Yeah. My next stream will be on Wednesday evening at 8 p.m. You can check my schedule. Go to the homepage of my Twitch channel, click on the schedule tab, and I have my schedule there. I'm debating on whether to, if I have time, if time permits, I am also debating on maybe adding some non-coding streams just for like, I don't know, gaming or something like that. That's what most people use Twitch for. I don't know. I'm thinking about it. If I have time, maybe doing some fun gaming with you guys. Obviously no obligation to attend. We wouldn't be talking about, anything like important related to class. We might just, gossip a little bit together. But yeah, it might just be fun. I'm thinking about it. But yeah, the actual class related streams or the streams with educational content will still be on Wednesdays and Sundays. Rascal says, one day in the future, you'll find yourself with no GUI available, only a command line, and you'll wish past you had learned it. I am assuming Rascal is speaking from experience here. But yeah, no, you got a point. So, all right. Well, I am going to wrap things up here today, unless anybody has any more questions. And yeah, I hope you all have an awesome rest of your evening. If you have some evening left to enjoy, and get a great start to your next week. Bye. All right, Silent. I'll see you later. Bye, Coder. Bye, Florence. Bye, Herpacion. Yeah, have a great night. Bye, Champo. Later. Bye, Ciara. All right, bye, Rascal. Talk to you later.